Reviewing the Kurji mechanism in our last video for introducing ozonolysis, throughout this video, we're going to focus on exactly when that carbon-carbon connection gets broken, reviewing the last three oxidative cleavage reactions we've reviewed, asking yourself, when exactly do we lose that carbon-carbon connection between the carbons that were double bonded together? If we were to summarize the cleavage caused by osmium tetraoxide, then treating with periodic acid, the reactions for functionalizing the double bond and cleaving the carbon-carbon connection are two separate reactions. First, we form the syn-1,2-diol with reacting the alkene with osmium tetraoxide. The original carbons of the carbon-carbon double bond still have a connection through the single bond, that only through a separate reaction with a separate reagent with periodic acid are we then able to cleave that original carbon-carbon connection, leaving us with carbonyl products. When looking at the lysis caused by potassium permanganate, we don't have separate reactions. However, we can shift reaction conditions to favor alternate mechanisms, since with heat and acidic conditions, it results in bond cleavage, a removal of that carbon-carbon connection, resulting in carbonyl products. With the same reagent, if we shift reaction conditions to basic and cold temperatures, we can favor an alternate mechanism that conserves a single bond between the two carbons of the original double bond of the alkene, resulting in the formation of a syn-1,2-diol. Reviewing the last two pathways for oxidative cleavage is going to help put ozonolysis in perspective. In this case, we don't have two separate reactions, we don't have shifting reaction mechanism. Both the functionalization and lysis of that carbon-carbon connection all happens within the formation of molozonide. Keeping track of the green carbons throughout this animation, with the formation of molozonide, they lose the double bond connection, and as molozonide spontaneously breaks down, they lose that single bond connection. The cleavage here with ozonolysis is spontaneous, all reliant on forming an extremely unstable intermediate that breaks down, and even though has a further mechanism to form a relatively more stable ozonide, the carbon-carbon connection has been broken. Putting this all together, we can see that with ozonolysis, we can't really separate functionalization and lysis by having a different reaction or changing reaction conditions. In this case, they're both mechanistically inseparable.